All right, so now we have these other formulas. They're all on the formula sheet. You're getting all these formulas. There's nothing much to do here. So if it says write the product of 2 cosine 27t cosine 15t as the sum of 2 cosine functions, we're doing product to sum. Does that make sense? Product to sum. So we look over at our formula sheet and we go product to sum. Y'all with me? All right. Now on your formula sheet, we want something that says cosine cosine. It's the bottom one, right? So we just write this as 2 times 1/2 cosine, well, u plus v. U and v are 27t and 15t. 27t plus 15t, right? And then minus, or plus, sorry, plus cosine of 27t minus 15t. So let's see, did I end all my parentheses? Yes. So does everybody see what I did? I just literally, honestly, literally plugged in numbers. I said u equals 27t and v equals 15t. Okay? And now we're just going to clean it up. This cancels with this, and I get cosine of, and I just add these two. That's 42t plus cosine of 12t. And that's the answer. And that's it. There's nothing more to do. Yeah, Griffin.
So do you always make the first number listed U and the second number V?
Doesn't matter. I don't care. I mean,
will it work out right?
It's going to work out because it's a plus between them. It's always going to be okay. If you change it, if it was like, say you were on this first one and it was sine U cosine V, well, it would definitely make a difference which one is U and which one's V, because the U goes with the sine and the V goes with the cosine.
Okay, yeah.
Right?
Yeah. But I guess that would be like a negative 12 and the signs would switch and it would still be a positive 12? Like in the, on the right half of the equation?
I feel like you're really going to complicate this.
I won't.
Plug it
right.
in. Like, do you want me to plug in one, like want me to make one with, here, don't go away. So does everybody have this?
Right.
Any questions about this? I don't want to erase it. I don't have to erase it. I'll just make a new page. So let's say I have sine, what do we have? Sine 27t cosine 12t. I think we had something, whatever. Good enough, right?
Mm-hmm.
Okay, so what do you want to do here?
I want to find one of the formulas they have sine and cosine, which is like the first one.
Yes.
And then I'll plug it in.
I just plug it in. So I have this equals 1/2, and then I have sine of what?
Sine, in parentheses, U plus V, so we'll make it 27t plus 12t.
Good. Okay, so there's my sine, and then?
Plus sine 27t minus 12t.
Exactly. Okay. So this becomes what?
No, I was agreeing with you. I just said
Okay, so this becomes 1/2 sine of 39t plus sine of 15t, right?
Right.
So that's it. I mean, you could distribute the 1/2, but that's either way is fine. There's nothing, literally nothing more to do here.
Cool. I like it.
You know what I'm saying? Don't make this complicated. This is super, super easy.
Yeah, compared to everything else.
Yeah, it's honestly just plugging stuff in. You do have to add the numbers together. So here's the mistake. I've seen it all. You have to add the numbers together. You can't leave it in this form. It will mark you wrong. And I will not go back and give you credit for it, because just add the numbers together or subtract the numbers, okay? The other thing that I see happening is this. This is completely wrong. Does everybody see why this is completely wrong? Is anybody not sure why this is completely wrong? I mean, like sometimes I'll have it, like it'll be 1/2 times sine of, say, 28t plus sine of 8t, and people will come in and say this is the sine of 14t plus the sine of 8t. No, it's not. So I want to make sure you understand. You can't go, like, you cannot say, just like you cannot say that 2 times the square root of 2, can you say 2 times the square root of 2 is equal to the square root of 4? No, you can't just put stuff into functions. And this is putting something into a function. This sign is taking the function of a number. So you have to do that first. Graphically, if you think about it, one changes things vertically and one changes things horizontally, right? If you think about transformations of functions. So they're not the same. Does everybody get this? Is there any questions? I'm trying to finish up real quick here because, you know what, I mean, we're pretty much done. Here it says, given y1 and y2, express the sum as a product. So I go sum to product. And I literally look at my formula sheet and plug these values in. Do you see what I'm saying? This is super, super easy. If it seems hard at all, then you need to talk to me because there's nothing to this. Okay? Y'all with me? Are you saying something to me, Griffin? If you are, just talk. It's fine.
Well, I just have a question that I thought of earlier, but I was going to ask at the end of class.
Yeah, sure. What is it?
Do you know, like, off the top of your head, like, how long these identities have been around, like, historically? Like, I was just curious, like, when did people actually figure this stuff out? Is it crazy?
Say it one more time. What?
I was just kind of curious, like, when did people figure this stuff out?
Well, this all comes from just trigonometry. I mean, the minute you start seeing how things are related in trigonometry, I mean, like we have this x, this y, and this hypotenuse, and it's really cosine, sine, right? Cosine and sine, and tangent is just a ratio of these. We can do so many things. I mean, they're all ratios related by the Pythagorean theorem.
Yeah.
I mean, if you, when you start doing calculus, you'll see why you need all these identities. One of my students one time told me that the thing that she got the most out of in Trig that helped her with calculus was identities.
Mm-hmm.
And it was, I think she said it for Calc 2. Because you have to do certain calculus, you have to be able to manipulate these trigonometric functions. And I can't really explain why right now because you don't know calculus, but you'll see how important this all is.
One day, yeah.
One day, soon. Sooner than you think.
Yeah. I'll take your word for it for now, though.
Thank you very much. I appreciate that.
You're welcome.
Okay. So I'm done.